All right, R6 rational exponents. Write each expression without negative exponents, evaluate if possible. So number 12, in parentheses, I have -5, and it is raised to the -2. It may or may not have actually been explicitly written in the notes, but, oh, yes it was. But my phrase for negative exponents is put it where it ain't, make it positive. So that means if it's on the top, we move it to the bottom. If it's on the bottom, we move it to the top. So in this case, it's on the top, so I move it to the bottom, and I'm going to have 1 over -5 squared. And so what is that going to be equal to? 1 over 25. (16) 4/3 raised to the -3. So this one's a little different in that the exponent is on the outside of the whole thing. And so when that happens, I take whatever's inside and I flip it. So this is going to become 3 over 4 cubed. And that gets rid of the negative exponent there. And so when we evaluate that, what do we get? 27 over. So when we have a cube outside, it goes on both pieces. So it's 3 cubed and 4 cubed. So it's 4 cubed. It's 4 times 4.
16
Times 4. 64. So 27 over 64. Let's see, 22. So this one is going to be a variable, and they tell us to assume all variables are non-zero real numbers. But we've got -b raised to the -4. So this one's a little different than 12, obviously, in that there's a variable. But the key difference is 12 had parentheses, and that exponent was on the parentheses, meaning it went to everything inside, which is why this 25 ended up being positive. But now, this -4 exponent is only on b, not on the negative sign. So when I do this, it's going to end up being -1 over b to the 4th, like that. So you got to make sure you pay attention to parentheses and all of that with your exponents for that situation there. Simplify each expression, write without negative exponents. So these ones are stuff like y to the 14th over y to the 10th, and we need to simplify that. So if neither of them are negative to begin with, because obviously if something's negative, we got to put it where it ain't, make it positive. But I need to simplify this, and so I need to move one of them around, but to keep away from negative exponents. So my phrase, the put it where it ain't, make it positive, you can also put it where it ain't and change the sign. Okay, so I'm going to move this one from the bottom up to the top because I know that'll keep a positive exponent for me. And so this is going to become y to the 14 minus 10. Okay, so I took this, and to move it from bottom to top, I had to subtract it off, and so ultimately this will give me y to the 4th. Any questions on how I can do that or anything? You done this stuff before? A little bit? Okay. Let's see, 32. I've got 15. They use S, but because my S's look so much like 5s when they're mixed in a problem, I'm going to change it to X. So X to the -4 over 5X to the -8. And I don't mind, like, if you do the same thing, if, like, it's written as one variable, but you want to do it as something else. Like, I don't care as long as, like, you're consistent throughout the problem. Don't, like, start as S and then change it to X and then be like, I think I want to do Y instead. Like, just make sure it's consistent. So on this one, we can reduce the 5 and the 15 to become 3. Now I have X raised to a negative power on top and bottom. Which one do we think I should move and why? Like, which direction should I go? Top to bottom or bottom to top?
Bottom to top.
Why?
Because the bottom's bigger.
Yes, the bottom is bigger, so when I add it, it's going to get rid of that negative exponent. And so this is going to be 3x to the -4 plus 8. And you don't have to write out this step if you, like, just do it in your head. That's fine. I'm just doing it for a visual. So this becomes 3x to the 4th. Now, if you had gone the other way and you went top to bottom, you would have just ended up getting on the bottom x to the -4 and then just had to move it. So it pretty much just gives you an extra step if you had done it that way. Not wrong, just trying to eliminate doing too many steps. Let's see. $38. I've got 3p to the -4 in parentheses raised to the 2, so that whole thing is squared. And then in another parentheses, p cubed raised to the -1. So first thing I want to do is deal with those exponents outside the parentheses to move them inside. And so that's going to give me 3 squared, which if you want to go ahead and write it as 9 is fine. And then p to the -8 times over here p to the -4. Nope, that's a 3. Multiplying, not adding. So now when I combine these, I'm going to get 9p to the -11, and then I just need to move that to make it 9 over p to the 11th. Any questions on those? Let's see, 46. Gonna get a little crazier. A lot happening in this one. In parentheses, I've got 8y squared to the -4. Then I've got 8y to the 5th to the -2, like that whole thing, over, in parentheses, 8 to the -3, y to the -4, and then that whole piece is squared like that. So where do we think I should start with this one?
Distributing the exponents on these.
Yep, distribute the exponents for each of the pieces that it's with. So I'm going to have 8 to the -4, y to the -8 times 8 to the -2, y to the -10 over 8 to the -6, y to the -8. Now what?
Cancel. Can't you cancel the y to the -8 on the top and bottom?
Yes. I was trying to see where you were going with the canceling thing. Yes, I can do that because they're the same, so that goes away. What else?
Multiply the top.
Multiply the top, and what is that going to give me on top?
16
So the base stays the same. I just add the exponents.
Oh, okay.
So it'll be 8 to the negative 6.
Forgot that.
Y to the negative 10 over 8 to the negative 6, which gives me, or what do I do? Cancel. So I'm just left with y to the negative 10 on top, which means I need to do what?
Oh, yeah.
Move it to the bottom, so I get y over 1 over y to the 10th. So anything that starts kind of crazy like this one did, it should end with something short and sweet like this one did. I'm not going to say it's going to be like, 1 over something, but if you still have something really, really chaotic at the end, you probably can take it farther unless there's like an excessive amount of variables. Sometimes a problem has like 3 or 4 variables in it. Obviously that's going to look a little crazy unless somehow everything canceled. So just be aware of that. The next one's just say to evaluate the expression, which is more or less what we've been doing, but just in a new section of it. So 48, I have 121 raised to the 1/2. What does an exponent that is a fraction mean?
Don't you have to not divide it, but
I think I know what you're trying to say, but
figure out how to say it.
or what is this equal to?
Is it
Half of 121.
is it the square?
Square root.
Square root of that.
Yeah. So it's the square root of 121 is what this is equal to. You don't have to write it this way, but I usually do just because of the visual for myself. But what is the square root of 121? 11. And so the denominator of the fraction of the exponent tells you what root it is. So if it was like to the 1/4, we would be taking the 4th root of something. So if I have one like 52, in parentheses, it's negative 8 over 27 raised to the 1/3. So this one means I'm taking the cube root of this. So the cube root, it just is like a square root, what with a little 3 there, of negative 8 over 27. Yep, and we're going to have the negative sign. So odd roots, we can, like, the sign will stay, but even roots, we can't have the negative inside. So this is going to be negative 2 over 3. Now a continuation of this is if I have something like 27 to the 4 over 3, like that, that means that I'm taking the cube root of it and I'm raising it to the 4th power. Now I will say probably 99 times out of 100 I take the root first, and then I will raise it to the power because I really don't want to deal with 27 to the 4th power. However, the cube root of 27 is something that I am comfortable dealing with, okay? So this is going to be the cube root of 27 to the 4th. What's the cube root of 27? 3. So this is going to be 3 to the 4th then. Times 3 again. 81. Let's see, 60. I've got negative 32 raised to the negative 4/5. What's different about this one?
The negatives in parentheses. Oh, no, the negative with the
Well, yes and yes. I have a negative in the parentheses and a negative in the exponent. So this is going to be the fifth, hold on. I'm going to move this to the bottom. 1 over, I'm going to go ahead and write this as the root now. The fifth root of negative 32 raised to the fourth. What is the fifth root of 32? 2. So this is going to be 1 over 2, but it's negative because we had this negative in here. In parentheses, raised to the fourth. And so what is negative 2 raised to the fourth? Positive 16, so I get 1 over 16 for that one. Last one, 62. I've got 121 over 100 raised to the negative 3/2. Any ideas what the what I need to do first?
Simplify the fraction.
To what? What do I notice about my exponent? Yep, so it's negative, so I need to flip. Now I'm going to be clear. Flip this fraction. The exponent doesn't flip. So this is going to now be 100 over 121 raised to the 3/2. Yep, I'm going to take the square root of 100 over 121, and then that whole thing is getting cubed. So what is the square root of 100? 10, and what's the square root of 121? So I have 10 over 11, and then I'm going to cube it. What's 10 cubed? 1,000. What is the cube of 11? I don't expect you to know that. You have your calculator. Can you multiply that? 1,331. Is that what you said? Okay. So obviously, I don't expect you to know like 11 cubed off the top of your head. You would need to type that in a calculator. So, anyways, any questions on any of this? Not too hard, right? Your problems for this section are 11, 17, 25, 35, 45, 49, 55, and 61. Yes.